All right, we are doing homework 11.5, which is on long division. And I'll do one long division one, and then we'll look at some of the harder ones in the back. The first one we're going to look at is, let's find a good one. Yeah, we'll do number 3, I guess. So this one we're going to divide k to the 4th plus 19k to the 3rd plus 89k squared minus 7k plus 16, and that's getting divided by k plus 9. Okay. Couple things to note right at the beginning that might be different for other problems is if there is ever a missing power of k anywhere, then we need to put in 0. So if there hadn't been 19k cubed, then what we would put here is 0k cubed. That way we have a good placeholder, or you have problems with trying to subtract things that aren't like terms. Another thing we can notice right away is that because 9 doesn't go into 16, there is no way that this divides in evenly. So there's going to be a remainder, and we'll see how that looks in just a minute. The first thing we're going to look at is we always look at the biggest power. How many times does k go into k to the 4th? The leading term of this, how many times does it go into the leading term here? K goes into k to the 4th, k cubed times, because k times k cubed is k to the 4th. Just like when you're doing long division in middle school, after you see how many times it goes in, you multiply this and subtract to see what's left over. K cubed times k plus 9. We're multiplying times this whole binomial. So k cubed times k is k to the 4th. K cubed times 9 is plus 9k cubed. And we are subtracting here. We are subtracting this to see what's left over. K to the 4th minus k to the 4th is 0. That will always happen if you put the right number here. That's why we chose it. 19k cubed minus 9k cubed is 10k cubed. Okay. K, we're going to bring down everything else. K goes into 10k cubed, 10k squared times, I guess I should use red again here, so plus 10k squared. And when we multiply that, we get 10k cubed plus 90k squared. We're going to go ahead and subtract that and see what's left over. 10k cubed minus 10k cubed is always a 0. 89k squared minus 90k squared is negative k squared. Bring down the rest. K goes into negative k squared. It goes in negative k times. Negative k times k is negative k squared. When we multiply that, we get negative k squared minus 9k. And when we subtract, something a little weird happens. We're subtracting a negative. When you subtract a negative, that's adding. So it's negative k squared minus negative k squared, which is negative k squared, plus k squared, which is 0. Similarly here, we have 7k minus negative 9k. That's the same as 7k plus 9k. We're subtracting a negative. And so what's left over is 16k. 7k minus negative 9k is 16k. Bring down to 6. K goes into 16, k 16 times. So we get 16k plus 9 times 16 is 144. We are subtracting that, so we get 138. K does not go into 138. And because k doesn't go into 138, this is our remainder. Two ways we can write this. We could write it as remainder 138. Oops, I put an extra 1 in there. Remainder of 138, but that is not as good as the actual correct answer. The final answer should be k cubed plus 10k squared minus k plus 16 plus 138 over k plus 9. It's still being divided by k plus 9. We didn't actually divide it. It didn't go into it, so it's still getting divided. Note that if this number the remainder had been negative, we wouldn't put plus and negative. We would just put minus whatever that remainder was. So this is our answer. And as we knew it wouldn't, it didn't go in evenly, and so we had a remainder. All right, let's look at some of the back. All right, number 7. Since negative 2, 0 is an x-intercept of g of x, what must be one factor of g of x? Oh, it said A said confirm g of negative 2 is 0. So this is g of x. G of negative 2 means we plug in negative 2 for x. So we've got negative 2 cubed plus 4 times negative 2 squared plus negative 2 minus 6. And we want to see what g of negative 2 is equal to. Well, this is negative 8. This is plus 16. And then this is minus 2 minus 6 is minus 8. Negative 8 plus 16 minus 8. 16 minus 8 minus 8 is 0. So g of negative 2, I should label it g of negative 2 equals 0. Okay. Because negative 2 is a x, negative 2, 0 is an x-intercept because it's a 0, then there must be a factor that divides g of x evenly, and that factor is x plus 2. Basically, g of x is going to be x plus 2 times some other polynomial. And we know this because when x is negative 2 plus 2 is 0, and 0 times anything will give you 0. But because we know one of the zeros, we know that this is a factor that divides evenly. And so let's actually do it. X plus 2 can divide into x cubed plus 4x squared plus x minus 6. And we'll start just the same way as before. We'll see how many times does x go into x cubed. It goes in x squared times. I am not going to do this one for you because we did it on the front. We just did a long division example. I will tell you that this one at least has a possibility of going in evenly because 2 can divide into negative 6. And so it does end up going in evenly. There ends up being no remainder. When you do it, there's no remainder. You get 0 when you subtract at the end. And so it's just a factor. Now, when you factor it, boy, I wish maybe I should do this. Let me do it in my head real quick. X squared plus 2x, is that right? 2x, no, I messed something up. I don't know. Maybe it's minus 2x. Let's do it real quick. Okay, x squared, so x cubed plus 2x squared plus x. X goes into that 2x times, like I said. And so we get 2x squared, okay, plus 4x. And when we subtract, we get negative 3x. And this goes in negative 3 times. And it does come out to be 0. So g of x is equal to x plus 2 times, because this divides into this, because, oh man, I was off the page there. I hope you guys might not have been able to see that. I hope that was not the case. Because x plus 2 goes into this, x squared plus 2x minus 3 times, and there's no remainder, that means that this times this had to give you g of x. So this times this gives you this. So g of x is equal to x plus 2 times x squared plus 2x minus 3. And this is not factored completely because we can factor this even more. This is x plus 3 times x minus 1, and this is the fully factored form of g of x. Okay, do one more. Number 9 is an example where it says p of x divided by x plus 2 gives you this stuff, and it wants you to find p of x. So there's some polynomial that when you do x plus 2, it gives you x squared minus 4x, let's see, x squared minus 4x minus 6, and then there's a remainder of 7, right? So 7 over x plus 2. And it wants us to find what this polynomial was here that when we divide it works. So notice that it didn't go in evenly. Let's see what we should do here. We want to solve for what p of x is, and let's just use some algebra we know. We know that if p of x is being divided by x plus 2, we can multiply by x plus 2 on both sides. We're going to multiply this whole side by x plus 2, and multiplying by x plus 2 cancels out with dividing by x plus 2, and so we're going to get p of x equals, which is what we want. Here, x squared is going to multiply times x plus 2. X squared times x is x cubed. X squared times 2 is 2x squared. Negative 4x is also going to multiply times x plus 2. Negative 4x times x is negative 4x squared. Negative 4x times 2 is negative 8x. Negative 6 is also going to multiply. We get negative 6x minus 12. The last thing is 7 over x plus 2 is going to multiply by this, and dividing by x plus 2 and multiplying by x plus 2 will cancel out, and we just get plus 7. P of x can be simplified. P of x is x cubed minus 2x squared minus 14x minus 5. So this is what p of x is, and you could confirm it if you wanted to. You could actually do the long division and it would come out exactly like this. All right, that's all the help I'm giving you on this homework. Hopefully the rest of it goes well for you. Good luck.